about new features of Java 21. Let's get to our agenda for today. So we will talk about why we are reviewing Java 21 updates. However, there are newer version of Java, like 23rd one is the latest for now, and in upcoming days we are expecting 21st version to be released. Also, we will talk about such thing as Java enhancement proposal, what is this, how it used, and we will touch such features like record patterns, pattern matching for switch, sequence collection interface, virtual threads, and as a bonus, we will see how to run features which are on the previous stage. I believe you can ask questions after each section because they're quite different. So let's get started. And just a few words about me. I'm software engineer with over 3 years of experience, work as backend and front-end developer. Also, I like climbing and trail running. And let's get started with the first question. Why we are reviewing Java 21, however, there are newest version of Java already released. And as you may know, there are two types of Java releases. The one is long-term support or LTS releases, and the second one is non-LTS releases. So what is the difference? For long-term support, we have support duration over 3 years after initial release. They are more stable because all updates aimed for crucial fixes and security patches. Maintenance cost is also lower because of this. And vendor supports also focused for LTS releases. On the other hand, non-LTS releases are having like 6 months support until the next version is released. They introduce new feature which may cause some system breaking because of changes. So you need to run system check and compatibility testing before migrating to the new version. And also vendor supports are focused on those versions just during 6 months, and after that they recommend to switch to the newer version. So to sum up, long-term support releases are suitable for enterprise projects, and non-LTS releases are good to access new features if you are leading some R&D, proof of concept projects, or doing some compatibility testing. And to give you an idea what is how efforts is get to upgrade Java treated as real estate renovation. So we all like a newly renovated apartment, but you won't do it quite frequently if it's not your day-to-day duties. The same goes with the Java version. So business wants to focus on their business goals and don't pay much attention on new releases until it's crucial for their goals. And here we come to the Java enhancement proposal. This is a tool via which Java evolves. So here you can see the screenshot from the JEP 0, which contains all other proposals related to Java. Those proposals can be bound with the language feature, with the syntax enhancement, JVM security, or tooling improvement. So anything what relates to the Java infrastructure may be submitted as a proposal. It will be reviewed, and next you can see the JEP lifecycle. So until some feature is released, it's come to the different stages, and it quite time consuming, and not all features comes to the final delivery stage. Just to give you an idea, so JEP lifecycle is pretty similar to the one we can see on our projects for our Jira tickets. Yeah, this is it. Let's move further. And here we come to our first feature, which is record pattern. Those are screenshots from the JEP page. Actually, let's check it on the web. So here you can see JEP page, and there is a lot of information, like technical one, who is owner of the JEP, its type, scope, release is going to be released. Also, there are a lot of information like summary, history, goal, motivation, some examples. So it's quite detailed information. And it's not just plain technical information, it's more like a guide for implementators. So the guy who will work on this feature completely understand why we need this feature, how it should be implemented, and what we are expecting after its implementation. And before we start with the new features, let's refresh in our memory how we work with typecasting for such construction like this. So for instance of, we are passing our object and check whether it's instance of the cup class. If it's so, then we need to declare a variable. We should explicitly cast it to the cup class type, and only after that we are able to reach its property. It was before Java 17, actually before Java 16, but let's stick with LTS releases. And after Java 17, we can see that it was simplified, and now we can assign a variable within the same line. We are checking the type on the instance of operator. And this is one step closer to using our volume variable, property. And after Java 21, for record type pattern, we can even deconstruct our records till its property. For example, here, we can not only check whether it's cup type, we also can declare its property and use them directly in our logic. And it's not limited just like this. We also can use nested records and deconstruct them as well. For example, here we can see T record, which contains T bag and cup. T bag has type property and cup has volume property. And let's imagine we need only those two variables to use in our further logic, and declaring them this way, we can use them directly without any additional variables. So this is a lot convenient than the previous step. Just one note that this is work for record type classes, and it doesn't work with the regular Java classes. So pay attention. If you try to do so with regular Java classes, you will end up with an error like this. And basically that's all for the record pattern. If you have any question, just let me know. If no, then let's move on. And the next feature is pattern matching for switch. And for this example, let's imagine the case when we are in the coffee shop and a barista should provide you with a price for coffee based on the drink type. For example, we will review it for latte, flat white, and espresso. And let's imagine that flat white may have an extra shot and the different price. So before Java 21, I would solve this problem like so, with if statement and instance of. So here we are checking whether coffee is instance of latte. If so, then we are checking whether it has extra shot, we'll provide corresponding price. If not, we will provide standard price. Then we check if it's flat white with a corresponding price. The same goes for espresso. If none of this match, we will return default answers that we don't know what type of coffee and we couldn't supply with the price. But now with the new switch case feature, we can do the following. So here we pass our coffee object to the switch case. And here we can also assert on type and assign a variable like for latte, for espresso. Also, we can deconstruct our record type classes till its properties like so. And also we can check whether certain properties fulfill certain condition like here. So after checking the type and assigning a variable, we can add when keyword and check whether has extra shot true or false. If it's true, we will go this way. If not, we will continue with other cases. And also what's new for the switch case, it's a null handling case. So you don't need to explicitly check coffee object for null before passing it to switch. Just add this additional case and handle nulls if needed. And that's it for switch case. Any questions?
Could you explain again about flat white deconstruction, this price and milk amount? How do we handle those? Are these part of flat white class?
So for this case, we are checking whether coffee is type of flat white, and if so, we can deconstruct coffee objects to coffee object to the price and milk properties. And after that, we are able to use them in our further code. Does it cover your question?
Yeah, almost. So properties, should it like all of the properties be included or only some of them can be?
Yeah, for Java 21, it should be all properties be included, but in the upcoming feature, we can replace them with slash and leave only the properties you need. But for Java 21, we have to declare all properties.
Okay, and I assume the order also matters, right? So this, because both of them are doubles, so I guess the order of them is important.
Probably yes, I haven't tried, but yeah, we can check that.
Okay.
Or names of property.
Or name of property.
So you mentioned that we have like to declare all the properties that are present in flat white record.
Yes.
Could you go back to the previous screen? I have also a question about previous screen. I remember.
Do you mean this one?
No, one more back. Yes, this about this when you have instance of T and then you provide like another classes inside. So it can be like multi-levels or just two levels supported. So if it has also properties, we can like go to the T-bags also objects or not.
It could be multi-leveled, and also for this deconstruction, we can deconstruct certain classes that we need and leave the other one with variable. So for example, for this deconstruction, we can deconstruct T back to the string type, and for cup, we can assign any variable, even don't declare the cup class, just name it like variable cup if we don't need its volume or the class at all.
But if, for example, if T-bag has also, for example, size, can we like open like T-bag and declare like take the
Yeah, we should declare all its fields.
So any amount, any depth of hierarchy is possible like to be extracted at this in this condition.
I'm not sure, but we can test it and see how it works if it's needed in the other meeting for the topics.
Thanks a lot.
Yeah, no problem.
We
Well,
have
any other questions?
yeah, Roman.
Yeah, I want to ask if we could use record pattern only with records in Java. We know that in Java 14 records was added, and it seems like we can use that syntax with records only. I haven't tried it with regular classes, but yeah, my question is if we could use record pattern with regular Java classes or only with records.
If we are talking about deconstruction only with record types, if you try to do it with regular Java classes, you will end up with an error. But if you want to assign a variable like so, it will work with regular Java classes.
Okay, yeah, thanks.
Any other questions?
Yeah, one more question. When you have return and switch, so we like move return from every case to the top of the switch. Can we use the same as if?
Same.
The next slide. We have return, and after that switch, one return for all switch cases. Previously, we used return for every case. Now we use one. Can we use the same with if or no?
Sorry, this return is for function. I just get part of the
Okay, I
code.
understand. For example, we should return it from some function. I understand. Can we use the same syntax when we have if, for example, return if some condition, else another condition? We have one return before if. Because I haven't worked with Java for a year or so. We use Kotlin in general, and we have similar syntax in Kotlin, like return if, and I'm asking if we have it in Java, in Java version. And I haven't worked with Java 21, so I want to know
Sorry,
if we can.
I'm not sure I'm fully understand about return if, but I haven't.
Okay, here we have return switch and some options. If we can use the same syntax with if statement, return after that if some condition, else another value.
Actually, no, if we use if, we will place return in the if statement.
Okay. Thanks.
Anything else? Okay, then the next feature is sequenced collection interface. And here from the diagram, you can see that a few interfaces were added under collection hierarchy, and sequence collection implements by list and dequeue, and sorted set and linked hash set implemented via sequence set. For the map hierarchy, it's sequence map interface, which implemented by linked hash map and sorted map implementations. So it's more about convenience. Those methods are, some of them existed for dequeue, and they just unified for other sequence collection. Also, the new method which is available now is reversed, which return collection in reversed view. Also, we need additional interface for sequence set because of return type. As we know, sets doesn't allow doubles, and here we need to explicitly return set type of the collection when we are calling reversed method. And let's check how they work. So here we can see them with a list. We have simple list with 5 elements. We will print initial order, we will try reversed order, we will access first and last element, then we will try to add first element and check whether it was changed. We will add last element and check also. And we will try to remove first and last element and check whether it was changed. So let's run the code and we'll see how it works. And we can see that initial order from 1 to 5, reversed order, then first element and last element corresponding to our collection. Then after addition, we can see that the first element was changed, same goes for the last. And after removal, we also can see the changes. So for linked hash set, it worked pretty much the same. There is no much difference with the list implementation. So the same method, initial order, reversed view, first last element, other elements after addition to the beginning and to the end of our collection. And we return to initial state when we remove the first and the last element, which were added here. The one note about sets, for the sorted sets like tree sets, you should be cautious with using method like add first, add last. So for those type collections, we don't have control over where the newly added element end up in the collection. And that's why when we try to call those methods on the sorted collection, we will receive an error, unsupported operation exception. So let's check it. And here you can see it. So all methods work well until we are trying to access to add the first element to the collection. And let's return to our presentation. So just for comparison, this is how we used to work with the first and last element for different type of collections. And now they're unified, and it's easier to access first and last element, also to get a reversed view. And as to exception, we already covered this case for collection with already defined sorting order when we can get unsupported operation exception. Also, if you try to add or remove some element on unmodifiable collection, you also end up with unsupported operation exception. Also, you may get no such element exception if you try to get some element from the empty collection. Do you have any questions so far before we move?
I have one. We
Yeah.
have unsupported operation exception when we want to add element to sorted collection every time, or for example, if that element is first one, for example, we have sorted collection 1, 2, 3, 4, and we want to add first element as 0. We will still have sorted collection because it's the lowest element in that sequence. Will we have unsupported operation exception in that case as well?
Yeah.
Okay.
Because we don't have control over where this element end up, and that's why for sorting collection, you will get the unsupported
Every time.
I believe yes. I didn't try all the cases, but
yeah, I'm asking about case when the first element is the lowest one in collection, and we want to add it to the as first one. So I'm asking about that specific particular case when element we want to add, for example, first or last, is the lowest one or the biggest one.
Let's try to do so. It's quite interesting for me as well. So we will comment all those methods until we are adding first, and let's comment this as well.
I think it's better to play with integers.
With integers?
Yeah, I think it's better because we know what is natural sorting for integer.
Yeah, let's adjust our code. And let's place 0 here. Yeah.
Yeah, we still have. Okay, thanks.
No problem. Any other questions? If no, let's continue with the sequenced map. So the methods are pretty similar and self-explanatory. Let's go through them. So we can, with method reversed, we can get a key value pair sequence in reversed view. We can get sequence key set, values, and entry set with those methods. Also, we can put first and put last, and note that we can get the value after this method. And method which were available for Navigale map and now available for all sequenced map. It's first entry, last entry, and poll first entry and poll last entry. So let's check how it works in the IDE. So the example is pretty much similar. So we have linked hash map here. This is initial state. We are adding 3 key value pair. Then we will print initial order, reversed view, first entry, last entry. Then we will try to put first and check whether it was changed. The same for the last. We will try to poll first entry and poll last entry and check whether the collection was changed. And we will check on those methods whether they provide corresponding response. So let's run the code and see the results. So here is our initial order. Here is our reversed view. First entry corresponds, and third entry, last entry also the correct one. Then we are trying to add first entry, and it was changed. The same goes for the last one. And after polling first entry, the first entry was changed. And the same for the last one. And the last 3 methods, sequence keys, values, and entries also provide this response. And the same, we talk about sorted sets. The same works for sorted map. All methods work pretty much the same, except for when we are trying to put first or put last. If we try to do so with a map, we will end up with the same type of exception.
Vladimir, Is the map sorted by case, by order of case, or by when you insert? If you, for example, swap 12 and 13 line, what is the output will be?
Let me check. 12 and 13.
Yes, just replace, like swap them, like insert third and then second. What's the
Okay.
output? Could you run everything, please?
Yeah. So because of sorting logic, we don't have control over where the element end up. It's completely,
Okay, so it's just based on the case.
yeah.
Okay, thank you.
Anything else? Okay, if no other question, let's continue. And
Yeah, I have one more, sorry.
okay, let's go.
About that sequence collection, do you have any like project experience, I mean real project experience using them? In which cases they might be used and might be useful? Do you use it?
On my experience, I didn't use sorted collection, more like with a list, with array list. But if you have any experience or any cases, we can review them or review on
Yeah, it
other.
might be used for some optimization, performance optimization when we sort some data very often, and it's better to have sorted, for example, collection when we put elements to it. So yeah, I'm just asking if you have any experience because it might be very useful, very useful.
Actually, that's a great topic for dedicated meeting. Probably we can prepare a dedicated report for it. Here we have just more like overview without any deep dives, just to understand what abilities provide us Java 21. Okay, and here is the jab about virtual threads. Just to give you some analogy, you can treat this big guy as a main threads and those yellow minions as virtual threads. So what is the difference? The platform threads is a thin wrapper around operational system threads. In terms of memory usage for platform threads, it's pretty high. Creation cost is also pretty expensive because involves system calls. Blocking behavior consuming a lot of resources and debugging could be challenging. And also scalability limited by operational system capabilities. On the other hand, virtual threads are managed by JVM, which mean far less overhead. They have smaller stack and shared resources, so they consume less memory. Their creation cost is cheap. Blocking behavior consume significantly less resources. And even we can continue write our code in standard sequential way without dealing with complex callbacks or futures. And due to this, debugging could be easier. Also, developers of this feature promising us that we can scale them to millions and they will work pretty fine. So to sum up, platform threads is still a good choice for high performance computing or graphic rendering, whereas virtual threads showing their best on blocking operations like calling database, other services, or any other IO operations. And here you can see the diagram where platform threads operates on operational system threads on top of it, and virtual threads work on top of the platform threads. In terms of migration, virtual threads are designed the same way, so you can, with less efforts, with small adjustment to the code, switch to the virtual threads. And in terms of backward compatibility, virtual threads are completely compatible with such Java interfaces like runnable, callable. So they integrate in the existing code base and libraries pretty easy. Let's refresh in memory how traditional threads work. So on some request to the database or any other service, there's still some period when CPU is not loaded until the response received. And if we have like many threads with such blocking operation, we can see that there is a space when the CPU is not loaded, and this is where virtual threads come into play. And to explain how they work, for example, we have platform threads, and one virtual threads come to the point where it gets blocked. And in this situation, JVM just put it in the queue and get another virtual threads which is ready to be executed. This way, we are fulfilling those gaps, and this means we are using CPU in a more efficient way, and overall, our system becomes more efficient. And to check what is the difference in the efficiency, I came up with a simple test. So here we will run 10,000 tasks for virtual threads and for the platform threads. So the difference is just thread type creation. Here we creation fixed thread pool with amount of available processors. And for virtual threads, we are creating thread pool per each task. And the test itself, it's simulating IO operation with 10 milliseconds of blocking. And we are writing down the starting time. We are arranging a latch to wait until all 10,000 tasks are finished. Then we are writing finish time, calculate its duration, and print it out to check what is the difference between those two types of threads. So let's run this code. Okay, so virtual threads completed in around 525 milliseconds, and for the platform threads, it took around 9 seconds. So the difference is pretty much significant. And of course, this is just a dummy test. I didn't experience on the real environment. If you will have any experience with applying them on the real project, it would be great to hear you out. So please share the experience if you have one. But currently it's looked quite promising, and we'll see how it goes. Okay.
Yeah, I have small comment. We had conversation about virtual thread during Java community last year, I think, and it would be great to add a link to that video as well in comments. So yeah, we discussed it a lot there.
Nice, thank you. Okay, any other questions, comment? If not, let's
I have one very quick, if you please. Sorry.
Yeah, okay, no problem.
The question is, for these virtual threads, how we specify stack size? I mean, in previous versions of Java, if worker thread pattern was implemented, like for example, Tomcat, it has a pool of threads which treats HTTP requests, and at some point you may do setup or startup setup of Tomcat in such a way that you specify stack size for platform thread, and this number multiplied by number of these threads could exceed actual heap number, and you may fail Tomcat with out of memory immediately. Is just maybe you know, is similar situation possible with virtual threads or not?
As far as I know, you can specify specific size of the virtual thread stack because it's flexible. So if the amount of resources a virtual thread needed, it takes. And I saw some tests where people try to run like 1 million virtual threads, and they took quite a time to complete, but they didn't fail the system overall. So I believe it needs additional investigation to find the point when virtual threads may crash the application.
Very nice. Thank you.
Yeah, no problem. And as a bonus, we will review how to run features which are on preview stage. So not all features which are released with Java available for production use. Some of them released for the preview just to get the feedback from developers and maybe make some improvements before it comes part of the standard JDK. And here, let's refresh in memory how we work with the strings, how we construct them. So we can use plus operator and put their variable and make some calculation. We can use message format in this way. Also string format and formatted of string class and string builder. And the feature which is currently in preview stage, it's called string template. And it will allow us to use str processor with the strings and put variables in them with the backslash and curly braces like so. We can also make some calculation within it and also call some methods within text block or strings. And if you try to run it in the standard scope of Java 21, you will end up with an error. So let me switch back to the error case so you can understand what I'm talking about. So if you try to run some preview feature on the standard scope of the Java release, you will end up with an error, and it will state that some of the feature might be under preview stage. And to run it, you need to check the following settings in your IDE, like project structure, modules, sources, and switch here to the level which allows this previews. And after apply, you will be able to run features which are on preview stage. Like so. And if the error with the feature flag persists, you can check additional settings under settings build execution deployment compiler, Java compiler, and add flag enable preview under command line parameters. And also you can add flag enable preview in VM options in run configuration, just in case the first one wasn't enough for you. And basically that's all. Any questions?